So if a human being, if you were to put on standard scuba gear and descend to a depth of about 100 meters, your body is instantly subjected to, well, it's like 10 times the atmospheric pressure we feel right here at the surface.
Right. It's a completely hostile environment for us.
Yeah, exactly. And if that same diver were to somehow, I don't know, plummet down to 2,000 meters, the pressure would just be catastrophic.
Oh, absolutely.
It would just instantly crush every single air-filled space in your body. I mean, the lungs would just fold inward, the sinuses would completely collapse. The human body is just fundamentally incompatible with the deep ocean.
It really is.
But today, we are looking at an animal that actively, intentionally collapses its own lungs, just so it can plummet 3,000 meters down into this absolute freezing darkness.
Yeah, and it's not just, doing this to survive a threat.
Right.
It's doing it to actively hunt. It's hunting sea monsters that are roughly the size of a school bus.
It's just wild. So welcome to the deep dive. For this conversation, we really want you, the listener, to kind of just leave the bright sunlit surface of the ocean behind for a bit. We've got this massive stack of research today. I mean, everything from these really old historical maritime accounts to like cutting edge bioacoustics and deep sea ecology papers.
It's a very eclectic mix of sources.
It is. And our mission here is to unpack all of this and understand an animal that honestly gets misunderstood a lot as just another, gentle filter feeding whale. But instead, what we're looking at is essentially a biological submarine. It's an alien intelligence and quite possibly the most extreme apex predator on Earth, the sperm whale.
A theater microcephalus.
Yeah.
And what makes the sperm whale so intensely fascinating to biologists, and frankly kind of terrifying when you really think about it, it isn't just its massive physical size, though obviously the size is staggering.
Oh, yeah.
Huge. But it's this vast, almost incomprehensible gap between what we can meticulously measure about its anatomy when it's just sitting at the surface and the massive mysteries that still surround its inner life when it goes down into the deep ocean.
I am so glad you're here to help guide us through all this research because these sources are dense. And honestly, the physical realities of this animal they almost don't even seem real.
They really challenge our understanding of biology.
For sure. So we're going to figure out how it survives that crushing descent, how it uses sound as this literal physical tool, how it sleeps vertically, which is crazy, and how it literally engineers the chemistry of our atmosphere.
It's a busy animal.
It really is, but I feel like before we can even attempt to understand how it survives a 3,000 meter dive, we really have to just look at how completely bizarre it is when it's just chilling at the surface.
That is exactly where we have to start. Because, its anatomy at the surface really tells the story of this crazy evolutionary arms race.
Let's start with the name, the sperm whale. I mean, it is, biologically speaking, a really terrible misnomer. And historically speaking, it's just a profound tragedy.
It's both, yeah. The name actually stems from one of the most, probably the most consequential biological misunderstanding in maritime history.
Right.
If you look back at the 18th and 19th centuries, during the absolute height of the global whaling industry, whalers were capturing these animals and literally cutting into their massive heads.
And inside the head, they didn't just find a normal skull and a brain like you'd expect. They found this vast enclosed reservoir of this pale, yellowish, kind of semi-liquid, waxy substance.
Exactly. The early American whalers and the sources actually trace this offshore boom back to figures like Captain Christopher Hussey. Right around 1712, they breached the heads of these animals, saw this massive quantity of milky white fluid, and they just completely erroneously concluded that they had found the whale's seminal fluid.
Wow. They literally thought it was semen.
They did. So they named the substance spermaceti, which translates from Latin to whale seed.
And it was because of that specific wax that they hunted this magnificent animal almost to the absolute brink of extinction. Because the research points out that spermaceti wasn't just some byproduct, right? It was basically the premium high-tech material of its era.
Oh, is the petroleum of the early industrial revolution.
Yeah.
Spermaceti is just incredibly unique. When you refine it, it burns with this absolute brilliance.
Almost no smoke, right?
Virtually no smoke and no odor. So it was used to make the finest, most expensive candles in the entire world.
Yeah.
And beyond that, it was the premier lubricant for all the first heavy machinery of the industrial age.
Because it didn't break down easily.
Exactly. It maintained its viscosity at really high speeds and high temperatures. It was in cosmetics, textiles, rust proofing. I mean, the entire global economy was just ravenous for this wax inside the whale's head.
It's just so tragic when you realize they were slaughtering the animal for the exact biological machinery that allows it to survive the deep in the first place, which, is why I actually really prefer the other name mentioned in the literature. Yes, the cachalot. The sources say some linguists trace that back to archaic French or Spanish or maybe vulgar Latin, and it essentially just means big teeth or sword hilts.
Much better name.
It feels infinitely more respectful for a predator of this magnitude,
It certainly fits better.
Yeah.
And if we're going to talk about this animal as a predator, we have to talk about the sheer unbelievable scale of it. Specifically, the extreme sexual dimorphism.
Right. This really stood out to me in the biology papers. We see sexual dimorphism, which, for the listener, is just a physical difference in size or appearance between males and females of the exact same species.
Yeah.
We see that in a lot of animals.
Sure, male lions have manes, female spiders are often way bigger than the males.
Yeah, exactly. But in the sperm whale, the size difference is just absurd.
It is one of the most extreme divergences you'll find in the entire mammalian kingdom, because both males and females are born roughly the same size, right? About 4 meters long. But as they reach maturity, their developmental paths just completely split. A mature female is going to grow to about 11 to 13 meters in length.
So that's around 36 to 40 feet.
Roughly, yeah. And she'll weigh up to maybe 15 metric tons.
I mean, a 15-ton predator is massive. That's basically the size and weight of a fully loaded city bus.
It's an enormous animal. But then you look at the mature males. A fully grown male sperm whale goes through this prolonged secondary growth phase. They don't stop at 13 meters.
They just keep going.
They continue growing until they reach 16 to 20 meters. That's nearly 70 feet long. And their mass doesn't just double, it just skyrockets.
Sure.
A mature male can weigh up to 57 metric tons.
Let's just pause on that number for a second so you can truly visualize this. 57 metric tons. If you took 8 fully grown adult male African elephants, right, and somehow stacked them all onto a single scale, that is the weight of one male sperm whale.
It's hard to even picture.
It really is. But why? Why would evolution demand that the male be almost 3 times the mass of the female?
Well, the biology papers suggest that this is actually the key to their entire ecological strategy. The females, because they're significantly smaller, are highly optimized for energy efficiency.
Meaning they don't have to carry around as much weight.
Right. They don't need to carry 50 tons of blubber. They stay in the warm subtropical and tropical waters near the equator all year round. They live in these complex cooperative societies to raise their calves.
And the warmth of the water means they expend way less energy just trying to stay warm.
Exactly. Thermoregulation is much easier. But the males don't stay in the tropics.
No, they head into the ice.
They do. Once a male matures, he actually leaves the warm waters and leaves the social pod. He begins this incredibly long solitary migration to literally the most extreme freezing environments on Earth, the polar seas around Antarctica and the Arctic.
And in those waters, you need the mass.
In those frigid waters, mass is survival. That immense bulk of 57 tons gives them vital thermal insulation. But beyond that, it just provides sheer unstoppable momentum.
Because they're basically a freight train.
Exactly. At that size, a male sperm whale is effectively invincible. There is literally no predator in the ocean, not even a huge, highly coordinated pack of killer whales, that would ever risk a head-on attack against an animal that outweighs them by a factor of 10.
So the evolutionary strategy is essentially, the females run society down in the warm waters, and the males just become these solitary, wandering fortresses of blubber up in the ice.
That's a good way to put it.
But regardless of whether it's a male or female, the most defining feature, the thing you immediately notice if you see one at the surface, is the head.
Oh, yes.
It does not look like the sleek, streamlined head of a blue whale or, a dolphin. It looks like a giant floating rectangular shipping container.
The cranial anatomy is truly bizarre. If you look at a mature male, the head alone can account for a full 1/3 of its entire body length.
That is wild.
You're looking at a head that is easily 5 to 6 meters, nearly 20 feet long, just a head.
And reading through the anatomical diagrams and the sources, the thing that honestly broke my brain is the asymmetry.
It's very pronounced.
Because almost all vertebrates on Earth, humans, dogs, sharks, eagles, we're all bilaterally symmetrical. If you draw a line straight down the middle of the skull, the left side is basically a mirror image of the right. But the sperm whale's head is profoundly, wildly lopsided.
It really is. To a casual observer, if you were just looking at a bare sperm whale skull in a museum, you might assume you were looking at an animal that had a severe birth defect. The bone structure is completely warped.
And the soft tissues are packed all around it unevenly. Even the blowhole isn't in the middle.
No, it's not.
On a dolphin, the blowhole is right on the top center of the head. But on a sperm whale, this S-shaped slit is pushed almost entirely all the way to the front of that rectangular snout, and it's shoved heavily over to the left side.
Which creates a very distinct visual signature. When a sperm whale exhales at the surface, the mist doesn't rise in a straight vertical column like other whales. Because of that left-leaning anatomy, the blow shoots forward and to the left at this sharp 45-degree angle.
Oh, so it's slanted.
It's very slanted. And historically, that angle blow was the exact telltale sign that whalers use to identify them on the horizon from miles and miles away.
Wow. But the sources are clear that this asymmetry, it isn't some mistake or a genetic defect. It's an evolutionary adaptation to house biological machinery, which we will definitely get into.
Absolutely.
But before we dive into the deep ocean with this animal, I have to ask you about the mouth. Because I was reading the section on their jaws, and I was genuinely so confused.
Dental anatomy.
Yes. Because you had this massive block of a head, right? And beneath it is this incredibly long, incredibly narrow, almost delicate-looking underslung jaw. And it's lined with these huge teeth.
Very large teeth.
The sources say there are up to 26 teeth on each side of the lower jaw, and these things are heavy, conical, and can weigh a full kilogram, over 2 pounds each.
And given that they hunt giant squid, the logical assumption that anyone makes is that those teeth are designed for tearing flesh, much like a great white shark or, say, a Tyrannosaurus.
Right, that's exactly what I assumed when I started reading. But then the anatomical papers explicitly state that the upper jaw doesn't have any functional teeth.
It doesn't.
It just has these fleshy, toothless sockets. So when the whale closes its mouth, the heavy bottom teeth just slide up into those upper sockets perfectly, like a lock into a keyway. It essentially forms a cage. It's not a cutting surface at all.
Yep.
So my big question is, if this is literally the largest toothed predator on planet Earth, and it lacks the ability to actually chew its food, how on earth is it consuming millions of tons of squid?
It is a brilliant question, and it really forces us to completely rethink how large marine predators operate. They do not chew, they do not bite and tear chunks off their prey.
So what do?
They use a biomechanical process called negative pressure suction feeding.
Okay, stop right there. How does a 50-ton animal create suction underwater without basically blowing out its own throat?
It's all about rapid volume expansion. So when the sperm whale approaches its prey in the dark, it doesn't try to clamp down on it with those teeth. Instead, at the last possible millisecond, it drops that narrow lower jaw and rapidly retracts its massive muscular tongue backward into its throat, almost like a giant piston.
Oh, wow. So it's instantly increasing the interior volume of its mouth.
Exactly. And physics dictates that a sudden increase in volume in a sealed environment creates a massive drop in pressure. The water outside the whale's mouth is at a much higher pressure than the sudden void that was just created inside the mouth.
So it just rushes in.
Violently. The water and whatever happens to be floating in that water like a giant squid is violently vacuumed into the mouth. The prey is essentially inhaled, completely whole.
It just inhales a squid the size of a bus.
Pretty much.
That is absolutely terrifying. But wait, if they hunt via this vacuum mechanism, why do they even have 2-pound teeth at all? Aren't they just kind of getting in the way?
Marine biologists have actually debated that for decades. We've found perfectly healthy, incredibly well-fed adult sperm whales in the wild that have severely deformed lower jaws, or some that are completely missing all of their teeth.
Really? And they're fine?
Totally fine. Their stomachs are still completely packed with squid, so the teeth are apparently entirely unnecessary for feeding.
So what are they actually for?
Well, the prevailing theory connects right back to what we discussed about those massive solitary males in the ice. It's highly likely that the teeth evolved primarily for male-to-male combat.
Oh, interesting.
Yeah. During the mating season, those 57-ton titans returned from the polar ice caps down to the tropical waters to compete for access to the female pods, and they become highly aggressive.
I can imagine.
When researchers observe mature males, they are frequently just covered from head to tail in these thick, parallel white scar tracks. And when you measure the distance between those scars, it perfectly matches the spacing of another male sperm whale's teeth.
No way.
Yeah, they are using those underslung jaws as literal weapons against each other.
So the teeth are just for gladiatorial combat during mating season. That's incredible. Okay, so we have this picture of the giant at the surface. It's this 50-ton, asymmetrical, lopsided, suction-feeding leviathan.
Very accurate description.
But to actually get to the food, to use that suction, it has to dive. And this is where the research gets truly mind-bending for me, because the descent of a sperm whale literally defies the physics of mammalian biology.
The transition from the surface to the deep ocean is really where the sperm whale stops being just a standard marine mammal and transforms into something resembling a highly advanced, biologically engineered submersible.
Right. So let's kind of track the dive here. A sperm whale rests at the surface, breathing heavily to prepare its body. Then it throws those massive tail flukes high up into the air, that iconic fluke-up silhouette that all the photographers love to get, and it just slips vertically beneath the surface.
And it barely makes a splash when it does.
The sources actually say this is deliberate, right? To reduce hydrodynamic drag and save energy.
Yes, exactly.
Because for the next 90 minutes, it is not taking a single breath of air.
Correct. It is leaving the only environment where it can legally breathe, and it's actively choosing to plunge down into an abyss. They routinely dive to 1,000 meters, frequently they go to 2,000, and they've even been recorded pushing nearly 3,000 meters deep.
Now, we briefly touched on the pressure in the introduction, but I really want to make sure we explain why this is so impossible. Let's talk about atmospheres.
Good idea.
At sea level, right now, you and I are currently experiencing 1 atmosphere of pressure. And we don't feel it because our internal pressure basically matches the external pressure. But water is incredibly heavy.
Very heavy. For every 10 meters you descend, you add another full atmosphere of pressure.
Right. So by the time a whale hits just 1,000 meters, it is dealing with 100 atmospheres of pressure.
Which equates to roughly 1,500 pounds of force pressing down on every single square inch of the animal's body.
And as we establish, an unprotected human diver would suffer complete, catastrophic failure of their air-filled spaces. But a sperm whale is a mammal. It has a trachea, it has lungs that breathe atmospheric oxygen, exactly like ours do. So how does it not suffer the exact same crushing fate?
The biological solution is deeply counterintuitive, but it's just beautiful in its brutal evolutionary logic. Think about human submarines. They're built with these incredibly thick hulls of titanium or high-yield steel to fight the pressure. Right, to keep the interior space rigid.
Yeah, to push back against the ocean.
The sperm whale does the exact opposite. It does not fight the crushing pressure of the deep ocean. It yields to it.
It yields to it. What does that actually mean for its skeleton, like in a practical sense?
It means their skeletal structure is designed to be highly flexible. A sperm whale's rib cage isn't rigid like ours. The ribs are bound to the spine by this highly specialized, very flexible cartilage. As the whale descends and the external pressure mounts, their chest cavity is designed to literally fold inward. The ribs compress, and the massive lungs are allowed to completely collapse on purpose.
Collapsing its own lungs? I mean, that sounds like a fatal injury if it happened to a human, but for the whale, it's just a survival mechanism. But wait, if the lungs are completely collapsing and flattening out, where does all the air go?
That is the genius of the system. The delicate, spongy air sacs in the lungs, the alveoli, which is where gas exchange happens, those deflate entirely. The air that was in those sacs is squeezed upward, pushed right up to the whale's upper respiratory tract.
So into the trachea and the nasal passages.
Exactly. And unlike the lungs, these upper airways are heavily reinforced with these dense, rigid, cartilaginous rings. They will not trush under pressure.
Okay, so the air is pushed out of the delicate absorptive tissue and safely locked away in this rigid biological pipe. But why does that matter so much? Like, what does that actually achieve?
It matters because of a fundamental law of physics called Henry's law. This dictates how gases dissolve into liquids when under pressure. And this is the entire reason human scuba divers get the bends, or decompression sickness.
Right. Let's break down decompression sickness really quick, because the sources mention it's a major threat. If a human breathes pressurized air underwater, the nitrogen in that air dissolves through the lungs and directly into the bloodstream, right?
Precisely. Nitrogen enters the blood and the tissues, and as long as the diver stays down at depth, the nitrogen stays safely dissolved, much like the invisible carbon dioxide gas dissolved in a sealed, pressurized bottle of soda.
But if the diver ascends to the surface too quickly, the surrounding pressure drops really rapidly.
The bottle gets opened.
Exactly. The bottle gets open. The dissolved nitrogen rapidly comes out of solution and turns back into gas bubbles directly inside the bloodstream.
And those bubbles act like microscopic roadblocks. They lodge in the joints, causing excruciating pain. They can block capillaries in the spinal cord, which causes paralysis, or they enter the brain and cause a fatal stroke.
So how does the sperm whale collapsing its lungs stop those bubbles from forming?
Because gas exchange, the actual transferring of nitrogen into the blood, can only happen in those delicate alveoli of the lungs. By forcing all the air out of the lungs and up into the thick-walled trachea before it dives too deep, the whale completely halts gas exchange. The pressurized nitrogen is trapped in an unabsorptive pipe. Very little nitrogen ever enters the whale's bloodstream, meaning there's simply nothing to bubble up when it returns to the surface.
That is just an unbelievable piece of physiological engineering. But, I was reading the pathology reports and the research, and it seems like it's not a totally foolproof system. They aren't entirely immune to the physics they're defying.
No, they are not. And this is actually a relatively recent, sobering discovery in marine biology. Scientists who have been examining the skeletons of older sperm whales, particularly the ones that have naturally washed ashore, they've found these distinct lesions on the bones, deep pitting and degradation.
The medical term they used in the paper was avascular necrosis.
Yes. A vascular necrosis essentially translates to bone death due to a lack of blood supply. And what's really chilling is that this is the exact same highly specific type of chronic bone damage we see in human commercial divers who have suffered from repeated low-level decompression sickness over a lifetime of diving.
So even with millions of years of evolutionary adaptation, they're still taking damage from the pressure. They're basically walking a very dangerous line every single time they dive.
It suggests that they are pushing the absolute physiological limits of mammalian life. They manage the nitrogen perfectly under normal conditions. But if a sperm whale is suddenly startled at depth, perhaps by an underwater earthquake, or say the incredibly loud ping of naval sonar.
And it panics.
Yes, if it panics and ascends too rapidly, the system fails. It can suffer decompression sickness just like a human.
Okay, so the lungs are collapsed to survive the pressure and avoid the bends. But this leads to a pretty obvious question. If the lungs are completely squashed flat, and they are actively swimming, fighting, and hunting for up to 90 minutes in the pitch dark,
Right.
Where's the oxygen coming from? It's a great question. I mean, we as humans literally panic if we hold our breath for 60 seconds. How are they moving for an hour and a half?
It's all about their internal oxygen bank. Since they cannot rely on oxygen stored as a gas in their lungs, they've evolved to store it chemically, directly in the tissues that need it the most.
Explain the chemistry here, because the contrast with humans is super fascinating.
Well, in the human body, the vast majority of our oxygen is carried in our blood, bound to a protein called hemoglobin, which basically carries it from the lungs out to the muscles. But the sperm whale relies heavily on a completely different protein called myoglobin.
Myoglobin.
Yes, myoglobin's job isn't to transport oxygen around the body. Its job is to store it locally. It sits directly inside the muscle fibers, just hoarding oxygen for future use.
And the sources note that the concentration of myoglobin in a sperm whale is astronomical compared to a land mammal. Like, it's so dense that if you were to look at a cross-section of the muscle tissue of a sperm whale, it isn't red like beef. It is almost completely black, like a dark, supersaturated, purplish black.
It is. Their entire muscular system is essentially just one massive internal scuba tank. They load the muscle fibers with oxygen when they're at the surface, and then they just slowly draw down on that savings account while they're hunting.
Wow.
Furthermore, they combine this with extreme physiological rationing. When they dive, their heart rate plummets dramatically, a biological process called bradycardia. Their heart might slow to just 3 or 4 beats per minute.
3 beats per minute?
Yes, 3 beats. And their circulatory system actively constricts the blood vessels to their extremities, basically shutting off blood flow to the skin and the outer muscles.
So they just focus the blood on the vitals.
Exactly. They shunned all the remaining oxygenated blood exclusively to the brain and the heart, because those are the only 2 organs that will suffer permanent, immediate damage without oxygen. The rest of the body just operates on its massive myoglobin reserves.
It's exactly like turning off the power to the rest of your house just to keep the refrigerator and the security system running during a storm. It's brilliant. But there is one more massive hurdle to this descent, and it brings us all the way back up to that giant, lopsided shipping container head, we really have to talk about the ballast system.
Ah, yes, the Malcolm-Clark hypothesis. This remains one of the most elegant, if intensely debated, theories in biomechanics today.
Okay, let me set up the physics problem here for the listener. We have a 50-ton animal. A huge percentage of that body is blubber, and blubber is just fat. Fat is naturally less dense than water, which means it's positively buoyant. It desperately wants to float.
Always.
So if I take a beach ball and try to drag it down to the bottom of a swimming pool, I have to fight the water the whole way down. If a sperm whale wants to dive to 3,000 meters, it would theoretically have to expend a massive amount of physical energy swimming downward against its own natural buoyancy, right?
Exactly. And expending massive amounts of physical energy means burning through all that precious oxygen stored in the myoglobin. If it has to swim hard just to reach the bottom, it's going to be completely exhausted before it even starts hunting.
Which defeats the purpose of the dive.
Right. From an evolutionary standpoint, fighting positive buoyancy is just an unacceptable waste of energy.
So the big question is, how do you get a buoyant object to the bottom of the ocean without swimming? And the answer, which I just love so much, is that the whale literally changes its state of matter.
It alters its own specific density. It is brilliant engineering. Let's look inside that spermaceti organ in the head. It contains up to 1,900 liters, hundreds of gallons of that yellowish liquid spermaceti wax.
Right, the stuff they made candles out of.
Yes. Now, at the whale's normal internal body temperature, which is around 37 degrees Celsius, roughly human body temperature, that wax is essentially a hot oil. It's liquid, it's less dense than the surrounding water, and it actively helps the whale float at the surface.
But when it wants to dive, it uses that weird asymmetrical blowhole setup we talked about earlier.
Precisely. Remember, the left nostril is the blowhole on the top of the head used for breathing. But the right nostril has actually evolved to act as this internal plumbing system. When the whale prepares to plunge, it opens that right nasal passage and actively draws the freezing cold ocean water from the surface directly into its head.
It flushes ice water through its own face.
It really does. It flushes cold water through this network of passages that wrap directly around the spermaceti organ. This acts as a biological heat exchanger. The cold water rapidly draws the heat out of the liquid wax, and as the temperature of the spermaceti drops, it undergoes a phase change.
It freezes.
It begins to crystallize.
Yeah.
It solidifies from a hot, buoyant oil into a dense, heavy, cold wax.
So suddenly this massive internal organ, which takes up a third of the animal's entire length, shrinks in volume and becomes significantly denser and heavier than the surrounding seawater.
Yes. The specific density of the head increases dramatically, generating a downward pull of nearly 400 newtons of force. The whale basically achieves negative buoyancy. It simply points its massive head downward, stops swimming entirely, and enters a state of unpowered freefall.
It just drops like a stone.
It plummets into the abyss, physically dragged downward by the crystallized wax in its head. It just glides effortlessly for thousands of meters, saving virtually all of its muscle oxygen for the violent hunt at the bottom.
Okay, I have to push back on this a little bit because while the physics of sinking make perfect sense, I just see a glaring tactical problem here.
What's that?
If a third of this predator's body has just transformed into a hardened, dense block of solid wax, how on earth does it physically maneuver? If I'm fighting a giant squid that can dart around instantly in any direction, having a giant anchor attached to my face seems like a terrible disadvantage. Doesn't that make it incredibly clumsy at the bottom?
It's a very valid critique, and it is exactly why the Malcolm-Clark hypothesis is still heavily debated among marine biologists today. How does it hunt with a heavy head? There are a couple of theories.
Okay.
Some researchers suggest that once it actually reaches the target depth, the whale might flush warm, oxygen-rich blood back into the capillary bed surrounding the organ, rapidly melting a portion of the wax to achieve neutral buoyancy.
Oh, so it can fine-tune its buoyancy on the fly. That would let it hover perfectly still in the water column.
That is the theory, yes.
Yeah.
Another argument is that in the absolute darkness of the midnight zone, extreme agility just isn't the primary requirement. The sheer mass and momentum of a 50-ton animal suddenly accelerating toward a squid might just negate the need for tight turning radiuses. The squid simply cannot outmass the whale.
That makes sense. I mean, the sheer physics of a 50-ton object moving through the water creates a wake you probably can't easily escape. But, you know, we're getting ahead of ourselves because we've just drop this whale into the midnight zone. It's free-fallen for 20 minutes. It is now at 2,000 meters.
Deep in the abyss.
And the defining feature of the midnight zone is that it is absolutely, utterly pitch black. Eyesight is completely useless down there. So how does it actually find these highly elusive squid in a total void?
It finds them by switching on the most powerful, complex sound production system that has ever evolved on this planet.
Let's talk about the sound cannon, because the bioacoustics of this animal are straight out of a science fiction novel. Walk me through the anatomy of how a sperm whale actually makes a sound, because it's not like a dog barking using vocal cords.
No, it is entirely different. We mentioned earlier that the right nostril basically migrated internally. Well, at the very front of the whale's massive snout, right near the tip, that internal right nasal passage narrows into a specialized structure called the phonic lips. Or, historically, whalers called them the monkey lips.
The monkey lips. Whalers were not great at naming things, but I guess it's descriptive.
To make a sound, the whale forces highly pressurized air through these phonic lips. They clap together violently, generating this sharp, intense acoustic click. But here is the critical part. That sound wave does not travel forward out into the ocean right away.
Right, because the anatomy forces the sound backward first.
Exactly. The click travels backward, moving through the entire length of that massive spermaceti organ we just talked about, using the wax as an acoustic conduit. It travels all the way back to the whale's skull. And resting flush against the front of the cranium is a structure called the frontal sac.
And the research describes this frontal sac as this incredibly strange surface. It's covered in these small fluid-filled knobs or papillae, and between these knobs are tiny little grooves that trap a microscopic, perfect film of air.
That trapped film of air is the key to the whole system. Because sound travels very differently through water and oil than it does through air, that air boundary essentially acts as a flawless acoustic mirror. The sound wave hits the frontal sac, bounces off the air boundary, and is reflected 180 degrees straight forward again.
So it fires back, hits the skull mirror, and bounces forward.
Yes, and on its way forward, the sound wave passes through the lower half of the whale's head, through a structure known as the junk.
The junk, again, incredible naming, but the junk is actually a series of highly organized, oil-filled cartilaginous lenses, right?
Exactly, it's a biological array of acoustic lenses. Just as a glass lens focuses light into a tight beam, the varying densities of oil in the junk focus the sound wave. By the time that click actually leaves the front of the whale's face and enters the ocean water, it is no longer just a scattered, messy noise. It is a tightly focused, highly directional, incredibly intense beam of acoustic energy.
It is weaponized sonar. And we have to talk about the volume here, because this isn't just a loud click. We measure sound underwater in decibels, just like we do in the air. And the sources state that the source level for a sperm whale's echolocation click has been recorded at an astonishing 236 decibels.
276 decibels is a number that is almost difficult for the human mind to contextualize. It is profoundly loud.
Let's try to break it down for the listener, because decibels operate on a logarithmic scale, right? It's not a linear increase like a speedometer.
Correct. For every 10 decibel increase, the sound intensity is actually multiplied by 10. So a 20 decibel increase is 100 times more intense. For context, normal human conversation is around 60 decibels. A construction jackhammer is roughly 100 decibels. If you are standing next to a commercial jet engine at takeoff, you're experiencing roughly 150 decibels of acoustic power, which is absolutely enough to permanently rupture your eardrums.
And the sperm whale is at 236. 236. Now, I know underwater decibels are calculated with a different reference pressure than decibels in the air, so it's not a direct one-to-one atmospheric comparison. But even with the conversion, bioacousticians universally agree that the sperm whale is the loudest animal to have ever lived on Earth. It is significantly louder than a thunderclap.
It is so astonishingly loud that it sparked one of the most intense ongoing debates in marine biology. The Big Bang hypothesis.
Yes. This is the idea that the sperm whale isn't just using this sound beam as a flashlight to see in the dark. It's using it as a literal weapon.
Exactly. For decades, some researchers hypothesized that at extremely close range, say just a few meters away, a 236 decibel acoustic blast focused directly at a prey animal would be powerful enough to physically debilitate it. Imagine a wall of sound so intensely pressurized that it overloads the central nervous system of a squid, disorienting it, or perhaps even physically stunning it before the whale even needs to open its jaws.
A biological stun gun. That is just a terrifying concept. But I have to ask you as the expert, is it actually true? Because if a squid doesn't have bones, and it doesn't have air-filled swim bladders like fish do, what exactly is the sound wave stunning? Wouldn't the pressure wave just sort of pass right through the water-dense tissue of the squid without doing much damage?
You've hit on the exact counter-argument that challenges the Big Bang hypothesis. Squids are essentially the same density as the water around them. They lack those rigid, compressible air spaces that would easily rupture under an acoustic shock wave. Recent experimental studies have attempted to replicate this effect, exposing squid to high-intensity sound fields in labs. And the results suggest that the acoustic pressure levels generated by a sperm whale might actually be an order of magnitude too low to physically paralyze or debilitate a cephalopod.
Oh, interesting. So the sonic weapon theory might just be a myth.
It is highly contested right now. Many bioacousticians now lean toward the idea that the incredible volume is purely for long-range, high-resolution tracking in a vast empty ocean. But, the sheer physical force of a 236 decibel click at point-blank range still keeps the stun gun question alive in the scientific literature. We just don't know for absolute sure.
Regardless of whether it stuns them or just tracks them with pinpoint accuracy, the whale is using this system to hunt, and the prey it is hunting is literally the stuff of nightmares. We are talking about the architects of our ancient sea monster myths: the giant squid, Architeuthis ducks, and the colossal squid, Misonychoteuthis hamiltoni.
These are invertebrates of a scale that is hard to even fathom. We are looking at animals that can reach lengths of 13 to 14 meters, over 40 feet long, with the vast majority of that length being their hunting tentacles.
And the anatomy of these squids is explicitly evolved to survive in the midnight zone. Let's talk about the eyes, because the giant squid possesses the largest eye ever recorded in the animal kingdom.
Averaging 27 centimeters across.
Yeah.
That's roughly the size of a large dinner plate.
Which begs the question, why does an animal that lives in pitch black darkness need an eye the size of a dinner plate? What is it possibly looking at if there is absolutely no sunlight?
It is looking for bioluminescence. In the midnight zone, the only light that exists is created by biological organisms. While the sperm whale is practically invisible in the dark, a massive 50-ton animal moving rapidly through the water column disturbs the microscopic bioluminescent plankton all around it, causing them to flash. The squid's massive eye is exquisitely evolved to gather every single stray photon of that faint blue light. It sees the glowing silhouette of the whale rushing toward it, giving the squid perhaps a few precious seconds to either flee or prepare to fight.
And if they fight, they are heavily armed. The sources describe the tentacles of the giant squid being lined with hundreds of suction cups. But these aren't smooth, soft suction cups like a common octopus. Each cup is reinforced with a sharp, serrated chitinous ring. It's like hundreds of tiny circular saws.
And the colossal squid is even worse.
Yeah. It has swiveling hooks on its tentacles to just rip into flesh.
They are formidable, incredibly dangerous prey. And yet, the sperm whale hunts them on a scale that defies human comprehension.
Yeah, this statistic in the biology papers genuinely made me pause and reread it like 3 times. The scale of consumption. Globally, marine biologists estimate that the population of sperm whales consumes roughly 100 million metric tons of deep-sea biomass every single year.
It is an astronomical figure. It's almost too big to picture.
Let me try to contextualize 100 million tons for you. If you take the entire global human fishing industry, every single commercial trawler, every net cast by every single fleet from every nation on Earth, combined humanity, pulls in roughly 90 million tons of seafood a year. The sperm whales are literally out fishing the entire human race, and they are doing it in the pitch dark.
They are a massive ecological engine, constantly transferring deep-sea energy into the global food web. And we have forensic evidence of their success because of what we find inside their digestive tracts. Because sperm whales do not chew, their highly acidic, multi-chambered stomachs break down the soft, gelatinous tissue of the squid very, very quickly. But they cannot digest the one hard part of the squid's anatomy.
The beak, which is made of chitin, basically the same tough material as crab shells or insect exoskeletons.
Exactly. The stomach essentially acts as an archive of the whale's recent hunts. And researchers examining the stomachs of deceased sperm whales have recorded finding up to 18,000 individual squid beaks inside a single stomach at one time.
18,000 sea monsters in one gut. It is a literal graveyard of titans. But what I find even more haunting than what's inside the whale is what is etched on the outside.
The battle scars.
Right. If you look at high-resolution photos of adult sperm whales, particularly the older males, their dark prune-like skin is just covered in these pale, circular patterns, perfect rings of white scar tissue concentrated around that massive blocky head and the jaws.
Those are the section mark scars left behind by the giant squids, fighting desperately for their lives, literally wrapping their serrated tentacles around the whale's face as they are being sucked into its mouth.
And the size of these scars is what blows my mind. Biologists have found perfectly circular sucker scars on whales that are themselves the size of dinner plates, which means the squid that left them must have been significantly larger than any physical specimen human beings have ever captured or found washed ashore.
And this highlights one of the most incredible realities of modern marine biology. We are actively estimating the theoretical upper size limits of one of the planet's largest invertebrate species purely by reading the forensic evidence left on the skin of its predator.
Because, and this is the craziest part to me, no human being has ever actually witnessed this hunt. With all of our submarines and remote-operated vehicles, we have never filmed a giant squid and a sperm whale fighting from start to finish. We've never seen it. We know for an absolute fact that this clash of titans happens thousands of times a day in every ocean on Earth, and yet we are completely blind to one of the greatest ecological dramas happening on our planet.
We are entirely locked out of the Midnight Zone theater. The encounters occur in absolute darkness, under miles of crushing water. We only ever see the scars on the survivors.
So, up to this point in the deep dive, we have painted a picture of a solitary, scarred deep-sea titan, a ruthless, highly engineered hunter of monsters. You would logically assume that an animal this extreme, living in such a hostile environment, would just be a cold, calculating, solitary killer.
Right, that would be the assumption.
But the research tells a completely different story. When you crack open that massive skull, the biology points to an animal capable of profound empathy.
It is a creature of deep social complexity.
Yeah.
And to truly understand that, we have to look at the brain.
Let's talk about the brain. The sperm whale officially holds the record for possessing the largest brain to have ever existed in the entire 4 billion-year history of life on Earth.
The physical mass is astounding. An adult male sperm whale's brain averages 8 to 9 kilograms. That is nearly 20 pounds of neural tissue. To put that in perspective, it is more than 5 times the mass of an adult human brain.
Now, I want to be careful here because I know that just weighing a brain doesn't automatically give you an IQ score. A bigger brain doesn't strictly mean smarter because a lot of that brain is just mapped to controlling a 50-ton body. The sources specifically talk about the encephalization quotient, or EQ. Let's explain what EQ is and why it's a bit tricky here.
The encephalization quotient is a metric biologists use to estimate the general intelligence of a species. It measures the ratio of the actual brain mass to the predicted brain mass for an animal of a given size. Humans have a very high EQ because our brains are massive relative to our small bodies. Some dolphins also have very high EQs. The sperm whale's EQ, however, is relatively low, much lower than ours.
Because its body is so insanely massive.
Exactly. When your body is 50 tons of mostly blubber and muscle, the math of the EQ formula skews significantly. But EQ is a very blunt instrument. It doesn't account for the absolute number of neurons, and more importantly, it doesn't account for the types of neurons present in the cortex. And this is where the sperm whale brain becomes incredibly compelling.
Right. The neuroscience papers in our stack highlighted a specific cellular structure that really caught my attention: spindle neurons, or as they are sometimes called, von Economo neurons. What are they, and why does it matter that a whale has them?
In mammalian neuroanatomy, spindle neurons are highly specialized, long-reaching brain cells. For a long time, we thought they were unique to humans and great apes. In humans, the density of spindle neurons is deeply correlated with our highest cognitive functions: social processing, emotional intelligence, empathy, grief, and complex communication. They allow rapid communication across large distances in the brain, facilitating quick, intuitive social judgments.
And the sperm whale has them.
Not only do they have them, but the sperm whale's massive cerebrum is exceptionally dense with these exact neurons. Along with elephants and certain other cetaceans, their neuroanatomy strongly suggests they possess an immense capacity for emotional intelligence. Biologically speaking, they are hardwired for intense social connection.
Which completely upends the cold-blooded killer narrative. And you see this deep social wiring immediately when you look at how they manage the most vulnerable part of their day: sleeping.
The vertical drift. It is arguably one of the most eerie, surreal, and beautiful animal behaviors ever documented in nature.
I watched the footage referenced in the sources, and it literally looks like CGI. For decades, scientists just assumed whales cruise slowly at the surface to rest. But in the early 2000s, researchers off the coast of Chile actually caught this behavior on camera. A pod of sperm whales will simply stop swimming, their bodies slowly rotate, and they hang perfectly vertical in the water column, completely motionless, face up, tail down.
Imagine being in a boat, looking down into the clear blue water of the open ocean, and seeing a dozen 40-foot-long gray pillars suspended in the abyss, utterly silent and still. It looks like an underwater Stonehenge or a sunken forest.
And the wildest part is how little they sleep. The data says they only engage in this vertical sleep for about 10 to 15 minutes at a time. Over a 24-hour period, they spend roughly 7% of their day sleeping. Compare that to humans, who need to be unconscious for a third of our entire lives just to function. How does a brain that massive, processing all that complex sonar data, recover on 15-minute power naps?
It is an open mystery in neuroscience. We suspect they might utilize a mechanism similar to unihemispheric slow-wave sleep, a process documented in other dolphins and whales, where they essentially put one half of the brain to sleep while the other half remains awake.
Just to make sure they don't drown or freeze.
Precisely. They maintain enough low-level awareness to regulate their breathing and monitor their surroundings. But the fact that they sleep in these synchronized vertical pod formations brings us to the very core of their society, the matrilineal unit.
This is where the story shifts from biology to sociology. And it's incredibly heartwarming, but also incredibly stressful when you realize the logistics of it. So we established earlier that the mature males are often the polar ice caps. The females and the calves stay in the warm tropical waters, and they form these tight-knit, multi-generational families. It is a strict matriarchy.
These are profound social bonds. A matrilineal pod consists of grandmothers, mothers, aunts, and calves. These family units can persist for decades, perhaps the entire 70 to 80-year lifespan of the animals. They travel together, they socialize, and most importantly, they solve the greatest biological challenge of their harsh environment together.
The babysitting problem.
Exactly. We discussed the crushing pressure of the midnight zone. A mother sperm whale must dive to 2,000 meters for an hour at a time to hunt giant squid. She needs those immense calories to produce the incredibly fat-rich milk her calf requires to grow. But the calf's lungs, its ribcage, its entire physiology are totally undeveloped. A calf cannot survive a deep dive.
If the baby followed its mom down to the midnight zone, it would be crushed instantly. So it has to stay at the surface.
Alone, drifting in the open ocean. Which, for a slow-moving, fat-rich baby whale, is essentially a death sentence.
So what do? They rely on cooperative daycare. While the mother plummets into the abyss to hunt, other females in the pod, the aunts, the older sisters, the grandmothers, stay behind at the surface. They escort the calf, they flank it, protect it, and keep it safely at the surface. The sources even note instances of alloparenting, where if a babysitting female happens to be lactating herself, she will willingly nurse a calf that isn't biologically hers just to keep it fed while its mother is hunting.
It is a remarkable level of trust, empathy, and social coordination. And it is absolutely necessary for the survival of the species because the surface of the ocean is not a safe sanctuary. It is a tactical war zone. And the sperm whale is not the only genius-level predator out there.
Which brings us to the one creature bold enough to attack them. Enter the orcas, the killer whales.
Or Canis orca. They are the apex predators of the sunlit zone, and arguably just as intelligent, communicative, and socially complex as the sperm whales themselves.
Right, so the orcas are smart enough to know they absolutely cannot take down a 50-ton adult male in the polar regions. That is tactical suicide. But a pod of female sperm whales with a vulnerable, slow-moving calf resting at the surface. That is a prime target. And the orcas hunt in coordinated packs. They are the wolves of the sea, communicating, relaying tactics, constantly trying to separate the calf from the adult mothers.
But the sperm whales have evolved a highly specific military-grade counter-tactic to defend against pack hunters. It is called the Marguerite Formation or the Rosette.
The daisy petal formation. When I read the description of this, my mind immediately went to ancient human warfare. It's essentially an oceanic phalanx. Let's paint this picture for you. The orca pack approaches. The sperm whales sense them. They do not scatter or flee because the calves can't outswim the orcas. Instead, they form a tight physical circle. They push the calves and any injured adults into the very dead center of the ring. Then the adult females arrange their massive bodies like the spokes of a wagon wheel,
with their heads pointing inward toward the calves and their massive tail flukes pointing outward toward the attackers.
And we have to remember the anatomy here. The head, which is so deadly to a squid in the deep, is a blunt instrument at the surface. It can't quickly snap at a fast-moving orca. But the tail...
The tail flukes of an adult female are 3 to 5 meters wide, composed entirely of dense connective tissue, and driven by the most powerful dorsal muscles in the animal kingdom.
Exactly. It is a phalanx of shields and spears. By pointing their tails out, they create a literal wall of churning, moving muscle and bone. A single, well-placed strike from a sperm whale's tail can easily shatter an orca's ribs, rupture its organs, or kill it outright. And the whales will hold this grueling defensive formation, sometimes for hours on end, lashing out at any orca that probes the perimeter trying to find a weak spot.
It is collective intelligence in action under extreme duress. And seeing this behavior raises a profound evolutionary question that biologists still wrestle with. We look at the sperm whale's massive brain, its deep multi-generational social bonds, and its complex communication. Did all of that intelligence evolve simply to hunt mindless squid in the dark? Or did it evolve because survival at the surface required outsmarting a highly organized predator just as cunning as they are?
It's an evolutionary arms race between the two smartest animals in the ocean. The brain didn't grow to hunt squid, it grew to fight orcas. I love that theory. And you just mentioned their communication, which is the perfect transition. Because if you are going to coordinate shifting babysitting schedules and instantly lock into a military rosette formation under attack without bumping into each other, you need to be able to talk.
And they do communicate continuously, but they do not use the loud, continuous echolocation clicks that they use for hunting. When sperm whales are socializing at the surface, resting, or defending themselves, they switch to a completely different acoustic system. These social sounds are called codas.
Okay, let's unpack the linguistics here. What exactly is a coda, and how is it different from a sonar click?
A coda is a short, distinct, highly structured, rhythmic pattern of clicks. Instead of a steady metronomic click, click, click to scan the water, a coda is a specific tempo, usually 3 to 12 clicks spaced out in very precise intervals.
Like Morse code, click, click, pause, click, pause, click, click.
It is highly analogous to Morse code. And what marine bioacousticians have discovered over decades of dropping hydrophones into the water and recording these animals is that these codas are not just random animal noises, they are distinct dialects.
Dialects, meaning they have cultural identity.
Exactly. Different matrilineal units of sperm whales form larger, loose associations called vocal clans. And every single clan has its own specific, unique coda dialect. It is their acoustic fingerprint.
The sources outline a fascinating scenario. Let's say you are off the coast of the Galapagos Islands. There are thousands of sperm whales in the area. But if two different vocal clans are swimming in the exact same waters, eating the exact same squid, they will not mingle. They will politely ignore each other. They only associate, travel, and babysit with whales that speak their specific dialect. They know who is us and who is them purely by listening to the rhythm of the clicks.
And here is the truly paradigm-shifting part of the research. This dialect is not genetically hardwired into their brains. It is a learned cultural behavior. Just as a human infant goes through a babbling phase to learn the specific phonetics of their parents' language, whether that's English, Mandarin, or Arabic, sperm whale calves actually go through an acoustic babbling phase.
They practice talking.
They do. Over the first few years of their lives, they practice and refine the timing of their clicks until they perfectly match the specific dialect of their mother's clan. They are actively passing down cultural knowledge across generations.
And the research is pushing even further now. With recent advancements in artificial intelligence and machine learning, researchers are processing thousands of hours of whale recordings, and they are starting to find a combinatorial structure to these clicks.
That is the cutting edge of cetacean linguistics. A combinatorial structure means they aren't just broadcasting a single static signal that means I am here. They are varying the rhythm, the tempo, and the sequence of the clicks in ways that almost look like phones.
Let's define phonemes for the listener, because this is crucial. In human language, a phone is a basic unit of sound, like a K sound or an ah sound. By themselves, they mean nothing, but when you combine them in different orders, they build words with infinite meanings. Are scientists saying sperm whales are combining clicks to build words?
We must be incredibly careful as scientists not to prematurely anthropomorphize and call it a human language with grammar and syntax. We don't have the Rosetta Stone yet. but the machine learning models strongly indicate it is a sophisticated, non-human combinatorial communication system. They are exchanging complex information. We are only just beginning to crack the code of what they are actually saying to each other in the dark.
It is genuinely awe-inspiring. It makes you realize we share this planet with another civilization, one that is older than ours, just operating on a totally different acoustic frequency. But their impact on the planet isn't just cultural. As we look at the broader ecological papers in our stack, we see that the sperm whale's biology literally shapes the chemistry of our entire planet.
They are a keystone ecological engine. And ironically, their most profound impact on the global climate begins with something as simple and unglamorous as their digestive cycle.
We have to talk about whale poop. It is scientifically important.
It is globally vital. Biologists refer to it as the whale pump. Let's look at the mechanics. Sperm whales dive thousands of meters into the midnight zone to feed on squid. Those deep-sea squidders are incredibly rich in trace elements, particularly iron and nitrogen. But because of the immense crushing pressure at those depths, the whale generally suppresses its excretory functions while hunting.
Which makes sense. You don't want to open any unnecessary valves when you're under 1,500 pounds of pressure per square inch. So they eat at the bottom and they hold it until they float back up.
Precisely. They return to the sunlit surface to breathe, socialize, and digest. And when they finally excrete waste, they release a highly buoyant, liquid fecal plume at the surface. This plume is incredibly concentrated with the iron and nitrogen they harvested from the deep ocean.
And why does that matter? Because the surface of the ocean is largely a nutrient desert, right?
Exactly. In the sunlit surface waters, especially in regions like the Southern Ocean, sunlight is abundant, but essential minerals like iron are severely limited. It is the primary bottleneck for life. When a sperm whale defecates, it acts as a massive, localized dose of premium deep-sea fertilizer,
which instantly triggers a biological chain reaction. Those nutrients hit the water, and massive blooms of phytoplankton microscopic marine plants suddenly have the exact chemical components they need to reproduce wildly.
And as those vast clouds of phytoplankton grow, they undergo photosynthesis. They pull carbon dioxide directly out of the ocean water, which in turn draws more carbon dioxide directly out of the Earth's atmosphere.
And the scale of this carbon sequestration is staggering. I want to highlight the math from the ecology paper because it's mind-blowing. Studies estimate that a population of just 250 sperm whales, simply by eating deep-sea squid and cooping at the surface, can trigger enough phytoplankton growth to sequester as much atmospheric carbon as 18,000 acres of dense terrestrial forest.
They are actively engineering the climate. They are mitigating the effects of excess carbon in our atmosphere, combating climate change, just by existing and following their natural biological cycles.
That is incredible. And speaking of their highly impactful digestive tracts, we cannot do a comprehensive deep dive on the sperm whale without addressing one of the most famous and valuable biological byproducts in human history, ambergris.
Ah, yes. Floating gold.
So earlier we mentioned the thousands of hard, sharp, chitinous squid beaks accumulating in the whale's stomach. Most of the time, the whale simply vomits those beaks back up into the water, much like an owl regurgitating a pellet of mouse bones. But occasionally, a beak slips past the stomach.
It slips into the whale's massive intestinal tract, which can be up to 300 meters long. A sharp squid beak scraping through the delicate lining in the intestines is a severe irritant. To protect its internal organs from being lacerated, the whale's digestive system secretes a waxy, cholesterol-rich substance that coats the beak, smoothing its edges.
Over months and years, more beaks get caught in this mass, and more wax is secreted around it, building up into a massive solid blockage. Eventually, this boulder of wax and beaks is passed out of the body, either excreted or sometimes it proves fatal to the whale. But once it's out, it floats on the ocean currents.
And this is where the chemical transformation happens. As it bakes in the sun and cures in the salt water for years, the foul-smelling fecal mass oxidizes. A specific chemical compound within it called ambrane breaks down, producing a deeply complex, earthy, musky odor. This is ambergris.
And for centuries, humans have sought it out. It has been one of the most highly valued substances in the luxury perfume industry. Because of its unique molecular structure, ambergris acts as a chemical fixative. If you blend it with volatile floral scents, it anchors them, making the perfume last exponentially longer on human skin. People have found lumps of ambergris washed up on beaches that sold for hundreds of thousands of dollars.
A multi-million-dollar global luxury industry, entirely reliant on the indigestion of a deep-sea predator eating giant squid. squid.
It's just wild. But the sperm whale's ecological generosity, if you want to call it that, doesn't end with its waste or its ambergris. It continues even after the animal reaches the very end of its life.
The phenomenon of the whale fall. When a sperm whale reaches the end of its 70 to 80 year lifespan and finally succumbs to old age or disease, if the carcass is not heavily scavenged at the surface, all 50 tons of that biological matter sink. It falls slowly back down through the twilight zone, past the midnight zone, until it finally impacts the barren, abyssal seafloor.
And we have to understand the economy of the deep ocean floor to appreciate this. Food is incredibly, devastatingly scarce down there.
It's a desert of mud. The organisms living on the abyssal plain usually rely on a slow, microscopic drizzle of organic particles drifting down from the surface, what biologists call marine snow. It is a starvation diet. So when a 50-ton blubber-rich carcass suddenly drops out of the darkness and hits the mud, it is an unimaginable windfall of energy.
It instantly creates a localized ecosystem out of absolutely nothing. And the biology papers break this decomposition down into distinct, fascinating stages. First, you get the mobile scavengers.
Within hours, the scent plume attracts deep-sea sharks, hagfish, and massive spider crabs. They strip away the soft tissues, the meat, and the blubber. This active scavenging stage can last for months, sometimes over a year, depending on the size of the whale.
Then comes the enrichment opportunist stage, where the sediment surrounding the skeleton becomes so saturated with decaying organic matter that millions of smaller organisms, mollusks, crustaceans, and specialized worms colonize the mud to feed on the leftovers. But the final stage, which lasts the longest, is the wildest biological trick of all.
The sulfophilic stage. Once the meat is gone, you are left with the massive skeleton. But a whale's bones are incredibly porous and deeply infused with heavy oils and lipids. As specialized anaerobic bacteria begin to break down those deep oils inside the bone matrix, they excrete a byproduct, hydrogen sulfide.
Now, hydrogen sulfide is highly toxic gas to the vast majority of life on Earth. But in the deep ocean, it is the fuel for life.
It fuels a biological process called chemosynthesis. Unlike plants on the surface that use sunlight to create energy via photosynthesis, deep-sea bacteria can use the chemical energy in hydrogen sulfide to produce organic material.
Which means entire complex communities of life. Massive thickets of tube worms, specialized clams, thick mats of yellow bacteria bloom out of the pitch-black darkness. They are drawing their life energy not from the sun, but from the chemical breakdown of the whale's decaying bones.
And what's truly staggering from a biodiversity standpoint is that marine biologists have discovered species of deep-sea worms, like the bone-eating Osidax worms, and various microbes that have been found literally nowhere else on planet Earth. They exist exclusively on the sunken skeletons of dead whales.
Which means in death, the sperm whale doesn't just feed an existing ecosystem. It physically becomes a unique, decades-long ecosystem.
It is a beautiful cycle, but it also raises a haunting historical thought. If the harpoon fleets of the 20th century had been completely successful, if humanity had hunted the sperm whale to absolute extinction just for the wax in its head, how many deep-sea species would have quietly vanished along with them, starved to death in the dark, without humanity ever even knowing they existed?
Wow. That is a heavy thought. So what does this all mean? How do we synthesize all of this research? Let's bring this massive journey together for you, the listener. We share this planet with an animal that is essentially a 50-ton biological submarine. It deliberately collapses its own flexible lungs to plunge into a crushing void. It hunts 40-foot-long dinner-plate-eyed sea monsters using a 236 decibel sound cannon in absolute darkness. It sleeps vertically, hovering like a stone pillar. It speaks in culturally transmitted generational Morse code dialects. It organizes communal daycare for its vulnerable calves. It fights highly intelligent killer whales in military phalanx formations. And simply by digesting its food, it fertilizes the ocean and helps regulate the climate of the Earth.
It is the absolute definition of a humbling creature. It forces us to reevaluate our definition of intelligence and our place in the global ecosystem. And yet, for all of their immense power, their mass, and their intellect, they remain deeply vulnerable.
They do. We still see the tragic headlines of mass strandings on beaches around the world. Sometimes dozens of healthy whales washing ashore at once, suffocating under the crushing weight of their own bodies on the sand.
And we still don't fully understand the mechanics of why these strandings happen. It could be navigational errors where the sloping sandy beaches fail to reflect their sonar clicks properly. It could be geomagnetic anomalies confusing their internal compasses. Or Increasingly likely, it could be the result of human-generated acoustic pollution military sonar or seismic air guns used for oil exploration, blinding their echolocation and driving them to the surface in a panic.
It is a stark reminder that the balance of the ocean is fragile, even for an apex predator. But as we wrap up this deep dive, there is one final, deeply provocative thought derived from the lifespan data in our sources that I really want to explore.
It centers on the concept of memory. We noted earlier in the dive that female sperm whales, the matriarchs of these complex societies, can easily live for 70, perhaps even 80 years.
Right. A lifespan highly comparable to a human's.
Which means, mathematically, there are matriarchs swimming in the oceans right now, today, who were born in the 1940s or 1950s. They were alive and swimming during the brutal, mechanized peak of 20th century industrialized whaling. They personally witnessed the factory ships. They heard the explosions of the harpoon cannons. They watched their mothers, their aunts, and their pods being decimated.
And we know, based on the neuroanatomy we discussed, that they have the largest brains on Earth, densely packed with spindle neurons for deep empathy and social processing. And we know they actively communicate complex, learned cultural knowledge across generations using their coda dialects.
So this raises an incredibly chilling question. Given their intellect and their communication, is it possible that these living matriarchs possess a generational cultural memory of the whaling fleets? When they gather in the safety of the Marguerite Formation and they pass their clicking dialects down to the calves, could their songs contain actual warnings about human beings? Do they tell the story of the ships?
That thought gives me absolute chills. The idea that we are not just observing them, but that they actively remember what we did and they're warning their children about the surface world.
We may never have the tools to translate that history. The Midnight Zone keeps its secrets well.
Well, on that haunting and beautiful note, we are going to head back up to the sunlit surface and end our descent here. Thank you for joining us on this deep dive. The next time you look out at the ocean, remember that over 80% of it is completely unmapped, pitch black, and utterly silent to us. But down there in the dark, the alien intelligence of the sperm whale is hunting, speaking, passing down memories, and shaping the very air we breathe. Keep exploring, stay curious, and we'll see you on the next deep dive.